What if your AI-generated 3D models could actually obey the laws of physics? Researchers from the University of Oxford just released something called DSO, Direct Simulation Optimization, and it's a game changer for 3D AI. Most current image to 3D models like TRELLIS can create visually stunning objects. But there's a problem. Many of these objects fall over or collapse when printed. Why? Because they're optimized for looks, not physics. DSO fixes this. DSO fine-tunes 3D generators using real feedback from physics simulations. You feed it synthetic or real renderings. Simulate how those 3D models behave under gravity and assign each one a binary stability label, stable or unstable. That simple label becomes the learning signal. Unlike older methods that rely on slow, unstable test time optimization or require ground truth 3D shapes, DSO trains the generator directly, faster and more reliably. It doesn't use pairwise comparisons or differentiable simulators. Instead, it learns from simulation feedback using something called direct reward optimization, or DRO. This lets the model understand what it means to be self-supporting. The best part? During inference, you can input even out-of-distribution images, stuff the model hasn't seen before, and it will generate 3D shapes that actually stand up. That means you can go from a random internet image to a 3D printable, physically sound object in seconds. This approach is faster than test time optimization and way more reliable. It even works without access to ground truth training data, letting the model self-improve by learning from its own simulation results. For engineers, designers, and anyone working with 3D, this unlocks a new level of realism and practicality. Imagine using this for robotics, rapid prototyping, gaming, or even AR and VR. Your AI models won't just look good, they'll function. If you're curious to try it, the paper and code are linked in the description. Like, share, and subscribe for more deep dives into the future of AI and design. And let us know in the comments if you'd like a full tutorial on running DSO yourself.